This is the vernier thermocouple. It's used to measure really wide ranges of temperature change. The real advantage of this is if you want to be able to measure something as high as a flame temperature, you can actually do this. The way this thing operates is that this is the actual sensor wire, and it ends up being plugged into the thermocouple. And this wire is replaceable if something happens to it, so you just plug it in there. And then the sensitive part of the detector is right down here at the end. And the way a thermocouple works is you've got a junction of dissimilar metals. And when you expose that to a temperature, then the device actually generates a voltage, and the voltage is dependent upon the actual temperature. Now this one actually has a built-in internal reference. Some thermocouples you actually have two wires and you have to put one in a reference temperature. This one has a built-in ice reference inside it, so you don't need that. And we'll just do a quick data collection. I'm actually going to put this into a flame, and we'll take a look at the flame temperature. But you can also go down as low as liquid nitrogen, so you could actually put it into liquid nitrogen. So it's minus 200 degrees C to 1400 degrees C is the operational range. So let's collect some data. It's an analog sensor, so I need to plug it into one of the analog ports, like channel 1. And we see our meter reading there. And if you look in the upper right corner of the screen, we see the default collection parameters, which is time-based, 2 samples per second, 180 seconds. This is the same setting that you would find with any of our temperature sensors or probes. They all default to a 3-minute time graph. Now for my experiment, I don't need that much time, so I'm going to shorten this up to 30 seconds. So I'll just tap there, change my duration to 30 seconds, hit OK. We're ready to collect data, so I'll press the collect button and then hold it into the flame. Now we have our data, and so we can take a look at it. At this point is where I actually put the thermocouple tip into the flame. So it begins to rise pretty rapidly, and then it kind of levels off up there, and so it gets to some constant temperature. We might be interested in that. And then at this point, I actually turned the flame off, and we see that it starts to cool back off again. For the analysis on this, probably we'd be interested in what was that maximum temperature. How hot was it in the flame? So this is a great use of the stats function. So I'll go to statistics, click there, and the maximum temperature was 877.3 degrees Celsius at 15.5 seconds. The vernier thermocouple, it's used for really wide ranges of temperature measurement, down to 200 below 0 Celsius, up to 1400 degrees, so down to liquid nitrogen, or if you wanted to place this into a flame or an oven, this would be the sensor you would use for that. For other uses, you might take a look at the Vernier website.